Okay, this is the third video in factorising an expression, and in this video we're looking at taking out a letter as a factor. In the last video we looked at taking out a number as a factor. So I'm going straight to examples again. Okay, so look at example 1. Okay, if we were asked to factorise, so for every single one of these the keyword is factorise. So if we were asked to factorise 2x squared plus 3x, if we look at this, there are no common factors that are numbers. Okay, the only number that goes into 2 and 3 is 1, and you wouldn't bother taking out a 1 because it would leave the same numbers inside the 2 and 3. And remember, factorise is putting back into brackets. So the first step is to put a pair of brackets, drop the plus sign in the middle. This is what we did in the last video as well. And then we look for a common factor that is a number first, and like I've just said, there are no common factors in numbers because this video is all about taking out a letter as a factor. And so then we look at letters, and we're looking for a common letter in every term. So in this term we have x's, we have x squared, which is x times x, and in this term we have x. So we have an x in every term. Now what that means is that we can take out an x as a factor. But how many x's can we take out? And when I say how many, I mean, can we take out x, x squared, x cubed, x to the power 4? Okay, so when you take out a letter, you're taking out a letter to a specific power. And the highest power of x we can take out is just x to the power of 1. Because this term, that's all it's got, is x to the power of 1. You can't divide it by x squared, although you could, but it would make it even more complicated. But we can easily take out an x from this factor, and we can take an x out from this term as a factor. Okay, so we can divide x into x squared, and we can divide x into x. So remember, what we do now to work out what goes inside the bracket is what do we need to multiply x by here to give us 2x squared. Well, of course the 2 stays the same because we didn't take any numbers out as factors. So x times 2 will give me 2x, but x times 2x will give me 2x squared. And what do we need to put in here? So that when we multiply this x by this term here, we end up with 3x. And of course it's 3. And you just double check. X times 2x is 2x squared. X times plus 3 is plus 3x. Okay, so there's example 1. I've got 8 examples altogether. Okay, so I'm going to move swiftly on, and you can go forwards and backwards and look at each one if you need to again throughout the video. So this time we're looking at 5y squared plus 7y cubed. Okay, so I'm going to factorise this, put a pair of brackets first, drop the plus sign in the middle. That's not going to change. There are no common factors that are numbers because this is that video. So then we're looking for a common letter, and obviously I've got a common letter in each term. I've got y's, so I've got y squared in this term and y cubed in this term. So the factors of y that I can take out of this term are y or y squared. The factors I can take from this one are y squared or y cubed. We need to take out the highest factor. Remember, the highest common factor is what we were taking out before. So we need to take out the highest power of y that we can from every term, and the highest power of y that we can take out is y squared, because this term can give me y or y squared. When I say give me, we can take it out from there, and this term can give me y squared or y cubed. So the highest that they can both give me is y squared. Then we work out what goes inside the bracket. Y squared times 5 will give me 5y squared, and y squared times 7y will give me 7y cubed. Let's double check. Y squared times 5, 5y squared. Y squared times 7y is 7y cubed, because y squared times y is y cubed. There we go. That's example 2. Example 3. Factorise 10x to the power 7 minus 9x to the power 5. So this time got some higher powers, and we got a minus in front, that in between our terms. Factorise, put a pair of brackets, drop the sign in the middle. No common factors in numbers, just letters. We've got x's in both terms. What's the highest power of x that is a factor of x to the power 7 and x to the power 5? That's really what we're asking. And the highest power of x that's a factor of both of these is x to the power of 5, because I can divide into x to the power 7, I can divide x squared, x cubed, x to 4, x to 5, x to 6 or x to 7. And this one from x up to x to the power 5. So the highest they can both be divided by is x to the power 5. So that's the highest common factor. That's the highest power of x I can take out from both terms. What goes here? X to the power 5 times what? Well, the 10 is going to be there to give me that 10. And then x squared is going to have to be there to give me the x to the 7. X to the power 5 times x squared is x to the power 7, and there's the 10 there. Okay, so x to the power 5 times 10x squared is 10x to the 7. That's what looks okay. The 9 is going to stay there because there were no numbers taken out. And x to the power 5, oh, we took all of that out, so we just write 9. X to the power 5 times 9 is 9x to the power 5. So that's now factorised. Okay, moving over here, example 4. Okay, so this time we're going to look at factorising 11a to the power 6 plus 3a squared minus 5a to the power 5. So this time we've got three terms, and we check to see if there are any common factors that are numbers. There are not in this video, but I'm always going to say to check. 11, 3, 5, they're all prime numbers, so the only thing that goes into 11 is 1 and 11. The only thing that divides into 3 is 1 and 3. The only thing that divides into 5 is 1 and 5. So there's no common factor other than 1, so we wouldn't bother. But we knew that because that's why this video is just about taking out letters. So factorise brackets, drop the plus sign there, drop the minus sign there. Got 3 gaps to fill and something to take out. Alright, so I checked it then to see if we have a letter that is common in every term. Yes, we do. A. Alright, what's the highest power of A that I can take out as a factor? Well, this term can give me from A up to A to the power 6. This term can give me from A to A squared. And this term from A to A to the power 5. So the highest power of A that I can take out as a factor from every term is A squared. You might start to notice something now, the more examples we do. Okay. Now we work out what goes inside. A squared times 11a to the power times what gives me 11a to the power 6. 11a to the power 4. There's my 11. A squared times 8 to the power 4, 8 to the power 6. A squared times what will give me 3a squared, well, just 3. A squared times 3 will give me 3a squared. And a squared times what will give me minus 5a to the power 5. Well, I need the 5. A squared times a cubed will give me a to the power 5. And that's now factorised. Okay, example 5. Factorise 4x cubed plus 5xy squared minus 3x squared. So this time I've got a couple of letters in the one term just to see if it's going to throw you a bit. Okay, no common factors that are numbers. Every example in this one I haven't put any common factors in numbers, just letters. Put my pair of brackets, drop my signs in. Okay, plus, minus. Okay, what's the common letter that is in every term? Well, as you can see, the common letter is x. We've got x cubed there, we've got an x in there, and we've got x squared in there. What is the highest power of x that is a factor of every term? This term can be divided by x squared, or x cubed. This term can be divided by x, and this term can be divided by x or x squared. So the highest I can take from all three, that's common to all three, is x. I can't take out any y's because this term hasn't got any y's and this term hasn't got any y's, so that's not a common factor of every term. Okay, x times what will give me 4x cubed, x times 4x squared, and x times what will give me 5x y squared. 5, well, I've taken the x out, so I need to put the y squared there. So x times 5y squared is 5xy squared. Okay, does that make sense? And x times what gives me 3x squared. Well, x times 3x will give me 3x squared. Remember, that is the way, like I said, I prefer to work out what goes inside, is to think about what multiplied by the factor we've taken outside here, here and here will give me what we started with. Okay, and you can double check it. Because remember, factorising is the opposite of expanding or multiplying a bracket. Example 6. Let's have a look. Factorise 2x y squared plus 3x squared y. Okay, equals brackets plus no common factors are the numbers. Let's look at what common factors are letters. We have x in this term, we have x's in this term, we have y's in this term, we have y's in this term. So this time we can take out x's and y's as factors. What's the highest power of x can we take? We've got an x here and we've got x squared there. The highest power of x we can take is just x. I've got y squared and I've got y. The highest this term can give me is y squared. The highest term this can give me is just y. So the highest they can both give me is y. Okay, then work out xy times what will give me 2xy squared. Well, 2y times xy will give me 2xy squared. 2 times the x and y times y gives me the y squared. Xy times what gives me 3x squared y. 3x. 3 x times x, x squared, and then times the y, and there's my y in the end. And that's that one done. Okay? Example 7. Nearly there. Factorise 7x squared y squared z to the power 4 minus 9x cubed y to the power 4 z cubed. Let's have a look. Put a pair of brackets, put a minus in between, so we're basically dropping that sign in there. It's never going to change. Okay, what letters have we got in both terms? We've got x's, we've got y's, and we've got z's. So we've got 3 letters we can take out this time. We do one at a time. Remember, I always tell you to break things down into smaller steps. Do one step at a time. So we look at the x's first. What's the highest power of x I can take out? Well, I can take out x or x squared from this one. This one I can take out x, x squared or x cubed. So the highest they can both give me is x squared. What's the highest power of y? That goes up to y squared. That goes up to y to the power 4. So they can both give me y squared. This goes up to z to the power 4. This goes up to z cubed. I can divide both of those by z cubed. So I can take out x cubed, x squared, y squared, z cubed. Now I've got to work out, be careful now. What here times this will give me 7x squared, y squared, z to the 4. Well, I need to put the 7 because I haven't taken any numbers out, so it's like an invisible 1, isn't it? 1 times 7 is 7. Now I've taken out the x squared, so I don't need to write any x. If I put an x there, when I multiply it by that, I'll end up with more. A higher power of x. I don't want that, so I've taken out the whole thing. I've taken out all of y squared. But from z to the power 4, I've taken out z cubed, so I need another z there, so that z cubed times z is z to the power 4. So this times 7z gives me this. Okay? 9. X squared times what will give me x cubed, x squared times x. Y squared times what will give me y to the 4, y squared. And z cubed times, oh, I took out the whole of z cubed, so I don't want to write any more z's in there. So that is my answer. That's my factorisation of those two terms. And the last one, last example, example 8. Factorise 5x squared minus 3y squared plus 4z z cubed. Okay, let's have a look. Well, there's no common factors that are numbers, like every other example, because this video is about taking out a letter as a factor. So then we look for common letters. Well, this term has got x's, this term has got y's, and this term has got z's. Well, there's no common letter in any of the terms. So this basically cannot be factorised. Okay, this cannot be factorised because we haven't got any common factors at all from every term. So it can't be done. And chances of that come out in an exam are unlikely, but you never know, they might try and catch you out. Okay, so when you look back through these examples, what you might notice is that the highest power of every letter that we took out was always the lowest power that we found in every term. So if we look at these two, we had x squared there and x. So what do we take out? X to the power 1. Look at this example. We had y squared and y cubed. What did we take out? Y squared, the lower power of the two. In this one we had x to the power 7, x to the power 5. What did we take out? X to the power 5, the lowest power of the two. In this one we had 8 to the power 6, a squared, 8 to the power 5. What did we take out? A squared, the lowest power out of every term. 3 terms this time. In this one we had x cubed, x squared. What's the lowest? X. So that's what we took out, because that is what you can divide into every term. This one, we had the lowest power of x was just x out of x and x squared, and the lowest power of y was y out of y squared and y. So that's what we took out. Same with this one, x squared, x cubed, took out x squared. Y squared, y to the 4, took out the lowest one, y squared. Z to the 4, z cubed, took out z cubed. Okay, so that's something you notice after doing it for a while. But when you are looking to factorise and to see if you can take out letters as factors, always remember, when you're working out what goes inside the bracket, think about multiplying your factor that you've taken out by this to give you this, and keep checking it. X times 2x, 2x squared, yeah. X times 3 is 3x, yeah, that's right. Okay, and if you take your time and break it down, then you will find it quite straightforward the more practice you do. Okay, thank you very much.